Hello. So obviously everyone thought this project was dead because I haven't talked about it for a couple of years at any meetings because it was always being done in the background. So I'm going to actually give you a status. This is probably one of the last statuses you're going to hear about it. It's been a project in the works for over 7 years. So it's that one. So we're getting ready for inclusion. So there are some final steps for this inclusion for submission. That's required. So some of the last stuff is the libcfs cleanup. And if you look at it, it's in sync with upstream, our native client. And it's almost done now. If you look at the code, there's very little left in that directory. This was one of the complaints, to have this library kind of module. Only the crypto handlers, there's some crypto handlers there. They can be moved out. And then the rest is left as the Lustre debugging structures and some of the glue to support older kernels. And then the debugging structures will eventually be moved to LNet. And then it'll be left as a module, kind of like Compat for OFED. So some of the changes that have occurred with that is one of the things is to use the debugging infrastructure, because some of the stuff is already moved, the setup for it. You have to load LNet now to start using the debugging structure. So they found that some people try to use lcuddle markers to inject into the debug log before LNet was, and that was a bug. So I told them, I said, well, now you have to load LNet module to use it. As a compromise, we gave a debugf file now. So if you want to actually inject stuff into your debug log, you don't even have to use a binary tool. You can script magic and just inject it in. So while you're running a live system. So that's actually a handy feature now for those people who hate using tools, which I've seen. Lots of cleanups. Arshad did a lot of cleanups. Lots of the debug macros have been cleaned up. We cleaned up the header, the libcfs private. So that is mostly done. So it's really trimmed up. The other big move that a lot of people are going to like once it's complete is all the debugging structure has its own kind of trace files handling, its own trace buffers. We're moving to the actual kernel ring buffer structure. So that way it'll minimize the code and there will be less duplication and things like that. So the nice thing is the work hasn't landed yet, because one of the requests is that we create a crash utility plugin for this. And so I've been looking to work on that and put that together. I haven't had the cycles to do it. So all those people out there who have your super secure sites and you don't want to do just crash dumps and have your private data of your users, this crash utility extension plugin will filter out only the debug logs, and you can actually send that off for analysis for your customer support. And of course, that plugin is written so it can support the ring buffer, and it's very much similar to the one that Red Hat does. So Red Hat has an ftrace extension plugin for crash. So it's going to be very much modeled after that. The other thing, Tom from Livermore, he suggested, we could do a dmessage-w thing with the ring buffer. So you can actually stream and watch your debug logs live on a live system in real time. Just watch it flow by. And so that way you don't have to do a DLDK and dump your logs. It will be a nice system. It's very much like the dev k-message structure that you'll have. So that's an actual real possibility for that. And I think that will be something very handy for administrators. Another thing, which isn't a hard requirement, is the fault injection system of the kernel. So there's an API for that. We kind of have our own custom one. There was discussions about doing that. That would be transparent. You wouldn't even notice the difference for that. But it does open up the possibility to add extra functionality to that. It's more than just setting a fail low. We'll be able to do a little bit more than that. There's a lot of injection handlers you can do for that. Interesting way to do further debugging of Lustre. And lastly, one of the last eyesores for the upstream kernel developers that they didn't like was our own implementation of a hash table. So there's an R hash table implementation, and we've been moving over to that for several years now. It's so piece by piece, we've been doing it. And on the client side, there's only one left, and that's the LDLM lock. So, and there is a patch for it, and it's in the works. It has some weird interactions with Quota right now because Quota interacts with the export locks. So there's been some test failures there. So we might have to, I'm looking into seeing that. But once that's done, we don't need to have the specialized hash table code for on the client anymore. So that will all be gone. As you can see, this is actually pretty much not a huge laundry list. And this is one of the most of the non-negotiables. The other one, which was the biggest requirement, as I said, upstream, Dave Miller was like, you have to support IP version 6. So, and this has been on the works for several releases. So this is one of those projects that when we looked at it, it touched everything. Change logs, config logs, everything. You wouldn't believe everywhere where the NID is used. So it was one of the largest changes. So we've been working on it for the last several releases. Even in 2.15, you'll notice that the internal core is actually using these large NIDs, but it actually only supports externally setting up IP version 4. And the good news is that the core of that work is actually done now. So IP version 6, as Peter said, for 2.16 will be released. Most things will be supported. There's a couple exceptions like GSS key, the more obscure things that are a hard requirement that haven't been finished yet. Another item related to LNet, which is we've gone back and forth on, is the OB2, the IB LND driver. So it's the InfiniBand guys do not like our driver for the simple reason they feel it's just too large. And for them, they look at it as a maintenance nightmare. So that is their main complaint. They're like, when it was upstream the client, they were constantly having to update our InfiniBand driver, and they would rather not have to update their drivers. So there's an abstraction layer that they developed for a lot of their drivers where most of them have been ported over to, so you don't have to deal with the turnover internals all the time. Though I have to say, for the last 10 kernel releases, I haven't seen much change in the InfiniBand layer. We've had very little problem with that, honestly. So to move to this InfiniBand layer, though, it could be done. We could simplify the driver, probably cut it in half in its size. The issue is in the NVIDIA GDS stuff. So they have to do their own RDMA kind of structure for their GPU tables. And because of that, that's a deep internal with the new API for InfiniBand. So it's very difficult to port that because you would lose that. So we'll have to make it optional to build it with the new APIs. And GDS is never going to be supported upstream. If anybody saw Linus's rant about GDS, it's never going upstream. There is an alternative to GDS, which I discussed with some people last night, that will probably happen within a year or two. So that's a big even if we clean up the InfiniBand driver, there's been discussions of do we want to submit it with the native client to ease the adoption? Or because we'll know that if we just submit it as it's now, there would be a lot of red flags and there would be a lot of screaming about it. And we might have to drop it anyways. But we do know it's critical for sites to use it. And of course, we've been backporting and then of course, LNet itself had changes done by Alvero upstream. Those we're waiting to backport to the OpenFS branch. The only reason we haven't done it is because those changes, RHEL 7. Not one of my favorite distros. It makes life a lot more difficult. But once that's dropped, we'll be able to change, and we're tracking all those changes, and we'll be able to incorporate those very easily. So those are all the LNet changes, which is good news. Is also those are near completion. And then, of course, we have our Lustre internals, our Lustre version itself. And these are actually in the works. So there's a couple. So when we did the upstream client, there was such a move to clean it up and make it acceptable for submission that some things were dropped in the floor for normal support. Like the interval tree was simplified, but we lost performance. So there were some performances enhancements that Lustre did. It did some tricks. The good news is that bless our users that make requirements like having excessive amounts of flocks and have to redo the interval tree. Because of that, we were just like, well, let's redo this properly and make it upstream compliant. So all those changes have been done. Those have been worked on in the last couple months. So the performance regressions are done. And one of the nice things that has come out of that is that, and besides the work from Tim Day for the OBD devices, we've worked on that. We introduced K-unit test. So people who don't know what K-unit test is, that's the stuff that like you ever seen kernels come up and said it checks the performance of this or that. That's what that is. So we actually can do performance checking and see for regressions of internals in the kernel with kernel code actually now. So that is a nice introduction, and that's being done for the interval tree. So the good news is all that work is now complete for, and it's in actually master next, so it's going to all land for 2.16. So that is another milestone. And then the other option, the other thing that broke upstream was the decache fixes. So there have been so there's a special path, the .lustre FID path that probably everyone knows here. There's some magic that's being done that causes some decache violations with it that we are working on to resolve. Upstream, you can't use that FID path, but once those fixes are done, and there's a patch in the works, Alex has reported that there were some nice rename fix races. So if you rename your files and you're using the FID path, sometimes you get two identical FIDs, D entries, and it shouldn't be. It should only be one. So those are also being. So once that's resolved, and my patch resolves that, but there's some regressions on state ahead. But with that, once that's resolved, we'll be able to move forward on that. But the worst part, of course, is none of these changes work with Rails 7. So Rails 7's decache operates differently, and it just doesn't work like modern decaches. So, and also we'll fix file sets with these changes as well. And then the last pain that I know everybody has probably dealt with, and is the death of proc. So upstream, they don't want anything in proc anymore. So the native client, the proc is gone. It's been gone for years. But the problem is that they have rules about sysfs, and only simple things go in sysfs. So a lot of things end up in debugfs, but only root is allowed to access that. So that's things like the list of pools, stats, target OBDs. These are things that are used by the liblustre library for a lot of common functionality. So that we haven't. So there's been a lot of delay in that and the native client to do this, because we have to figure out the alternative solutions to do this. So the other problem is, of course, is when we were doing these movements, and it's not just the movement of proc to sysfs, but we found that additions of proc files sometimes can be broken. So there is a ticket to create some test to validate that no one breaks tunables, because there has been in the time that tunables were misnamed and all kinds of fun things like that. So we have had that. And I have worked on, and I do have a solution for the non-root access. So I've used a netlink solution for stats. So instead of opening your thousands of proc files, you can just open a single netlink socket and collect that data. So it's actually multiplex, and you can you can stream it in multiplex and open multiple stats. So while this is seems like a nice clean way, and the performance is actually about the same because all the data is presented in proper YAML format. The only thing is that it takes a little bit more work to get this going. And because of that, there's been some pushback about it because you can't write a couple lines of code. So there was a ticket, and this anyone who's really good at writing Python wrappers and things like that, I would really love to talk to you about that, because I would love to write some plugins so that way you write your one line of code and you're happy and you can collect your stats and life goes on. So you don't have to, so it's not a burden to the users. And out of that, actually, there's some actually interesting abilities with that comes out of that. Like we can get subfields of YAML files. Another thing I have considered doing is that currently stats collects stats of everything. And that's very expensive on our system. So one of the things is that I would love to see in the future is we could create our own YAML config files to say what stats you want to collect, the actual counters, and disable the counters that you don't care about. And that would be a lesser load on the system. That would be an incredible enhancement. And of course, we have to do the target OBDs and the pool list. And I have patches already for those. And one of the patches there actually creates the foundation for that. So those things are in the works to be resolved. There's a couple nice to have, and we already have. So this might come to a shock to you because I know nobody knows this. There's 2 mount targets now for Lustre. So normally you do your mount -t Lustre, but there's actually a -t Lustre _ target. That's for the server side, because we were separating the server code from the client code, because client code was being executed with server code to mount server mounts, which doesn't make any sense. So we've been breaking those apart. That work was completed in the native client. We haven't completed it all in the upstream client because there's some weird server stuff going on with the Portal RPC layer. Because one of the benefits of that is currently when you start Lustre and you load your module, LNet comes up and all this infrastructure comes up, and then you mount. Now, with the new procedure, the goal is that when you load your module, it's super lightweight. Only when you mount does LNet come up and Portal RPC, which makes actually sense, better sense. And that way it doesn't consume your memory until you mount. And then when you unmount, it actually cleans that all up. So right now, if you unmount, Portal RPC and everything's still running in the background in LNet, and it's expensive. So this way you can have much lighter clients if you want to unmount. Another nice feature is that our sysfs files are not ALSR compliant. They're considered security violations because we use pointers to define them. So one of the ideas is to use the UUID to change the name for that. So in theory, we could actually mount with UUID like a lot of normal file systems. So that's in the works as well. And then, of course, we're going to remove the cached mount points. So internally, the kernel stores its mount points for reasons. Because remember the issue I told you about the Portal RPC layer running when you go to mount and it's still running? Well, there's a nice race, and there's one test that shows this, that sometimes when you try to shut down your file system, have you ever noticed you get this eBusy? That's because the Portal RPC layer is still trying to drain. So we've tried, there's a workaround with a umount helper to actually work around that. That hasn't been finished. And then we would use, and of course, the last thing that would be a nice cleanup is the HSM to move it from the file pipe that's being used right now to netlink. All right. So once that's all done, then it's just a matter of minimizing the difference to trees. We've had a long-standing ticket for that. That's LU 6142. That's been open for at least 5 years. The cleanups are always happening. Tim Day has done some great work on updating the check patch stuff. This is something that the upstream people get all tidy up about. And then another thing that has been neglected, the most neglected, is the Sphinx document style. So the kernel moved to Sphinx to create documentation for the kernel. I don't even know what will come out if you try to build it. Nobody does. And I kind of ported it in the upstream client, but no one's ever looked at it. That would be something to do. And of course, as we go on, as Peter pointed out, we're constantly updating support for native clients and kernels, thanks to Ubuntu and things like that. We're always patching for these newer kernels in GCC. So it keeps the work to support these newer kernels is actually at a very minimum. Currently, the native client is lagging because of the FS script API. The behavior of that completely changed around 5.10, and I've been trying to resolve that because Lustre has a chicken and egg problem with FS script. The newer API requires the inode to be instantiated already to get the FS script, but we need the FS script keys before the inode. So I have to figure out a clean way to get around that problem. And of course, lastly, once this is submitted, we have to deal with the handling of the native client with what we currently run with OpenSFS. So we're going to have to rework the tree so that we can build just server RPMs, because people are going to want to run the native client with the server RPMs. So we'll have to sort that out. That's kind of, some of that work has been done, but there's more to be done. All right. And that's all the material. This is probably one of my shortest talks ever. Usually Peter always was chasing me off stage and saying you're going overtime, but actually a lot of this work is near completion. And so it's a much easier talk now, and I'm probably finishing a little early. So the nice thing about this project is it's been a community effort. So there's people to thank. Neil Brown for really pushing this forward and interacting with the kernel community for accepting this and making sure that the barriers are lowered. Arshad, that guy, he's a hero for this guy does all the stuff that no one likes to do, all the cleanups and everything. Sean from HPE, he's done a great job for new kernel support. I like to think Timothy Day, he's contributed a lot of work from Amazon. And of course, Chris Horn, he's been a great help with the IP version 6 work. And the WAM Cloud team, of course, because they actually review these patches and test the stuff. And like the interval tree, Yang Shen has done a great job with helping move that work forward alongside us. Yeah. So that's the conclusion. As you can see, it was the least amount of talk, least amount of slides. So I'm not going to consume a lot of your time, and you won't fall asleep on me. As you can see, the last 6 months, there's been a lot of heavy development in these final issues, getting that complete. So there's been more development in the last 6 months than last 5 years to get this work done. So that has been really great. And once the IP version 6 work is done, I can focus on cleaning up and finalizing the native tree. I should have put the URL. It's on GitHub. It's at J.A. Simmons, 1973. There's a kernel tree there, and it's the branch Lustre. This is the closest we've ever come to completion of this work. So this is excellent news, and hopefully this is my last talk on it. You'll never hear about this again. Well, you'll hear about the server stuff. So once we're done with that, we're not done with the whole work yet. We're going to do the server stuff. And I would love to actually thank DOE for graciously actually allowing me to earn money and eat while doing this kind of work. A lot of companies would be not so tolerant to this kind of work, so I'm very thankful for that. Any questions?
Thanks. Thanks, James. I have a question about, you mentioned several times you cannot add this new feature because of the Rails 7 support.
Yeah.
Can you explain why is it a problem? Can you just do if Rails 7 else?
Yeah, I kind of had to do that, especially for the rhash. So one of the problems is the RCU it was really reworked in newer kernels for the old kernel. So a lot of times when we try to use RCU locking and stuff, and especially LDM locks, you get millions or billions of these locks. So at the end, you try to flush them with the RCU. And what happened is there would be so much flushing that the rail kernel would just tip over and it just couldn't flush it. It would just give up and it would time out and it never finish. That was the biggest problem. We saw that with the X-array stuff that we used when we saw it with the R hash table. That's all very heavily RCU dependent. And in fact, in a lot of the drivers, a lot of the kernel modules, you will actually see RCU barrier sync commands because we're trying to like work around that issue and try to flush it before it tries to flush itself to minimize that. So that's a big one. And the decache stuff just behaves differently. So when we try to do the fixes, there would be decache corruption in RHEL 7. It just works differently. Any other new kernels, it just behaves properly. There's missing, the infrastructure changes are missing. It's a 10-year gap.
Yeah, thanks.
Hey, James. Just curious on the timing of the inclusion. I know you mentioned Work and I were very close. Is there a specific target in kernel that we're going to include this inclusion? And the second question is, if RHEL 7 is giving so much problems and it's older, why don't we just ignore it and just focus on the newer kernels? So kind of a twofold question there.
I can answer the RHEL saying. Oleg. It's his test suite. So we run a debug kernel to test for spin locks and stuff like that. So right now we're in a transition from his RHEL 7 setup to a RHEL 9 setup. But what's happening right now, there's a lot of problems. So we have to get past to make sure we don't have like might sleep issues and things like that. The RHEL 9, as Oleg has shown, there are several issues. We have KSAN issues. We have some lock depend issues there. So we have to squash those to move to his debug setup for RHEL 9 so we can catch these issues, memory leaks, things like that. So once those are squashed, we can drop RHEL 7 support. That's the barrier for that. And what was the second part of the question? Oh, so I would say, like I said, the interval tree is done. We have the R hash table for the LDLM. That patch is in the works. It's a matter of just getting that to the final working. And I think that could land in a month or two. I mean, there's people who want this patch because there's some potential performance improvements over what we have now. And then the FID cache stuff, like I said, there's a actual desire to get that fixed because there's like a rename race condition that's been reported, and that fixes that. So once those things are landed, we can integrate it and then push it up, of course, and then resync the native client. So we're probably talking like 6 months of work. To be safe. You know the saying, you double what you think it will work. I would say it's like 6 months. Though, mind you, I've been saying this for a long time, but actually, like I said, it's a small list now. Oh, and don't forget, there's going to be fireworks when we actually submit it. There's going to be a lot of feedback. So we'll have to see what the fallout of that is.
So one of the things I forgot, because I guess I'm too tired. When you're going to ask a question, please say your name and the institution you're affiliated with so we can learn everyone. I know a lot of you got to go to San Diego. I didn't, so I'm still got to remember everyone's face and name. So if you would please do that. So Jesse's going to start us out.
Hey, I'm Jesse Hanley from Oak Ridge. So James, when this lands, and I guess like looking 5-10 years from now, I guess client side, what do you see? Like, do you see the upstream like client like using whatever the LTS is, or like is that going to be whatever like a distro chooses to like fork off, or like how do you see that? Like, what version
Whoa,
that keeps up to date?
that we have talked about. So it is a matter of timing because the kernel does have LTS releases. So now the pressure is going to be, that is probably when we're going to do our LTS because the distros do that. And I have to say that distros are, even RHEL is doing a better job now. It's every 2 years you get an LTS. So it's not too different than what we're experiencing now. But it is true. It's no longer on our timetable when the LTS will be released with this. And one thing we have agreed is not to try to push the client to an LTS target kernel. That would look bad. If we do it like before an LTS release and get it in and let it massage there for a while, that will be much more acceptable. I've had that discussion with Neil about that.
So, James, related to Kevin Harm's Argonne National Lab, sort of a tangent to what John and Jesse have asked. When do you think would be the point where, let's say, a majority of deployed Linux clusters would choose to just use the Linux native kernel rather than a packaged one?
That will definitely be when it starts to show up in things like RHEL. I think probably, no doubt, like Ubuntu actually, when it was upstream, it did actually start showing up. And there was in Ubuntu, and it was turned on. Ubuntu will be like, they'll turn it on as soon as it lands. So whether you like it or not, it'll be turned on. RHEL was like, it was in staging. I don't know what their policy will be if we are mainstream, if they'll turn it on by default. It could be that they do. We'll have to see what that works out.
So you think still a couple of years?
It'll be a couple of years, yeah. Whenever that release where they take that kernel. And like I said, RHEL is better at it, so it could be, if it's done in 6 months, the next RHEL release after that, because they'll be doing like a 6-something kernel. So,
all right. Any questions for James?
I just wanted to make him walk across the room. Makia, System Fabric Works. You mentioned in the mount client that you're trying to add in all the LNet tear up, tear down.
Yeah.
Is the vision removing? So some people use LNet for testing
No,
networks.
You could do LNet independent.
Okay, that's what I wanted to make sure.
Yes. No. You can do LNet independent. In fact, I will go over this in my IP version 6 talk. Okay. There's a ticket to do the reverse. Like now you have to do LNet, bring it up, and it talks to Lustre. There is something that can be worked where Lustre initiates LNet. You mount it and it goes out and it says, do LNet discovery, bring up the LNets, and then turn on Portal RPC.
Okay, cool.
Yeah. No LNet configurations needed.